For the today's session, we are going to learn about the introduction to Buckingham Pi Method. So at the end of this session, you can state the Buckingham Pi Method and you can able to derive the equations using Buckingham Pi Method. In the dimensional analysis of physical phenomenon, the relationship between the dependent and independent variables is studied in terms of their basic dimensions to obtain the information about the functional relationship between dimensionless parameters that control the phenomenon. This is the introduction of this dimensional analysis. There are two methods, one is Rayleigh's method and second is Buckingham Pi method. But before that, we must know what is a dimension. We are all very aware about the units. Units, take the example as area. The unit of area is meter square. But in dimensions, we can write this as a L square. So dimensions are these. These units are we are going to convert in MLT system. Mass, length and time. Their relationship that we are going to see with Rayleigh's method as well as Buckingham Pi method. Rayleigh's method is having a lot of restrictions. For variables increasing more than 4, this method is not workable. Let us see. This method is a conceptual tool used in engineering. This method expresses, that is the Rayleigh's method expresses a functional relationship of some variables in the form of exponent equation. Suppose if A1 is a dependent variable, dependent that means, take an example as discharge Q is equal to area into velocity. Q is dependent or independent? Dependent. Area, it is dependent on area and velocity. Like this, if A1 is a dependent variable and A2, A3 up to AN are independent variable in the phenomenon, mathematically we can write A1 is equal to K is a constant on remaining all the terms. Where K is a dimensionless constant, the dimensions of each of the quantities A1, A2, A3 are written and the sum of the exponents which we are going to put exponents of MLT of both the sides we are equated and then the equation is formed. This method is simple for small number of parameters. It becomes very cumbersome and tedious when the variables are increased. So the Buckingham Pi method comes in existence. This method minimizes the difficulties of Rayleigh's method. It states if there are n number of variables which are dependent as well as independent in the physical phenomenon, and if these variables have m number of fundamental dimensions, what are the m? M is MLT, 3. They are 3. Then the variables may be grouped as n minus m. If 7 variables are there, 7 minus 3, 4 dimensionless terms will come in existence. These dimensionless terms are known as pi. Let us consider the similar way of Rayleigh's method and then we will continue with that. Let us consider a variable x1 depends on the independent variables, that is x2, x3, x4 as shown up to n. Then the functional equation we can write as x1 is equal to k into bracket the remaining term. x1 is a dependent and remaining all are independent terms. We also can write function of all these x1, x2, x3 up to xn is equal to constant. If there are n variables and m fundamental dimensions, then according to Buckingham Pi theorem, f1 function is equal to pi 1, pi 2, pi 3 up to pi n minus m, because n they are a number of variables and m fundamental you can say quantities, that is MLT. So n if it is 7, 8, 5, 6 whatever it may be minus 3, those are your pi terms. Then the pi term is dimensionless and independent of the system. Now these are the steps of this particular method. Write the functional relationship, then write the equation in the general form which just now we have seen. which is equal to 0, that functional relation, that general form is equal to 0, find the number of pi terms, n minus m. Then select m number of repeating, and one more thing, in this the word comes select m number of repeating variables and write separate equations of each terms. Repeating variables and non-repeating variables. We have to select the repeating variables in such a way that they all contains all the dimensions, but togetherly they will not form a dimensionless number. Then you have to select the variables such as uh, one is fluid property, one is geometric property, one is flow property. Then the dimensions of same properties we cannot take as a repeating variables. This some 3-4 you can say criteria are there for taking selecting the repeating variables. So each pi term contains the repeating variables, and non-repeating variables we can take on the side, and we can find out the equation. Okay, variables written in the exponential form. Pi 1, I will just go for only one, that is pi 1 is equal to x1 raised to a1, x2 raised to b1, x3 raised to c1, x1, x2, x3 are the repeating variables, and the remaining one is x4. Similarly, for pi 2, you can take x1, x2, x3, and the remaining non-repeating variable x5. For pi 3 also, x1, x2, x3, and the remaining non-repeating variable as x6. So x4, x5, x6 are non-repeating, x1, x2, x3 are the repeating variables, and then you can go for the pi n minus m. See this equation, where x1, x2, x are the repeating variables, and each pi term solved by principle of dimensionless of the variables. In each pi term, find out the value of the exponents a, b, c. We have kept x1 raised to a1, then x2 raised to b1, that is we are going to find out what are the values of a1, b1, a1, b1, c1, a2, b2, c2, like this. Now put the values of exponents in terms of pi terms and write the functional relationship between all these terms and find out the equation. Okay, now these are the steps, simple steps, but we can understand these steps when we are going to solve the problem. Okay, this is one of the important problem. Now go slowly with this. The head loss in a horizontal pipe in a turbulent flow is related to. Now what are the dependent variables and what are the independent variables, just see. Is related to the pressure drop delta P and is a measure of resistance to flow in the pipe. It depends on the diameter, it depends on the viscosity, depends on the density, depends on the length of the pipe, depends on the velocity and surface roughness, and they ask you to show that. Now these all the lines are there, 1, 2, 3, 4 lines are there. They have written about that particular phenomenon, and they ask us to show that delta that is delta P upon rho g is equal to V square upon 2g, comma L upon D is the function of Reynolds number and the surface roughness. See, all these lines, they are converted into that is a small equation. That equation we are going to form. Okay, see clearly. For solving any problem in dimension analysis, we must know the correct dimensions of each and every property. Okay. Now, what are the different parameters are there that we'll see. First is diameter. The dimensions of the diameter is length L, velocity, the dimension of velocity meter per second, that is Lt raised to minus 1, density rho, the dimension is ml raised to minus 3, length L, dimension is L, viscosity mu, the dimensions is m, L raised to minus 1, T raised to minus 1, surface roughness nu, you can take any constant here, but it is a constant, so m raised to 0, L raised to 0, T raised to 0. Pressure drop delta P, it is m, L raised to minus 1, T raised to minus 2. I repeat, for solving any problem in the dimension analysis, we must know the dimensions of each and every parameter. Now choose dV rho as a repeating variable. I told one is the fluid property, one is geometric property, and one is flow property. So I have chosen dV and rho, and remaining is delta P. Okay. Like this, we have to go. Like this, we have to find out the relationship. We have to find out the relationship, and we have to equate with respect to exponents. Okay, we have to equate with the exponents which are 0 on the left hand side. So d is L, V is L t raised to minus 1, and rho is L, you can say rho is m L raised to minus 3, and delta P, it is m L raised to minus 1 t raised to minus 2. D, V, rho are repeating variable, delta P is non-repeating variable. This gives the relationship 0 is equal to C plus D, that is C. See the uh, here C, okay, here, that is we are going for M, so for M 0 on the left hand side. Like this you can find out the equation 0 is equal to C plus D. Similarly it is for M, this is for L, this is for T, okay. Like this you can find out the equations of all these, equate these exponents, and resubstituting we get delta pi 1 as delta P upon V square upon rho, pi 2 as rho D upon mu, pi 3 as L upon D, pi 4 as roughness coefficient, and from this we can relate pi 1 is equal to function of pi 2, pi 3, pi 4, equate all these in all these pi 1 to pi 4 terms, you will get this equation which they have asked. Delta P upon rho G is equal to V square upon 2G L upon D is function of Reynolds number, Reynolds number, and it is a surface roughness, hence proved. Okay, so this is also V square upon, you can remember this is a Darcy-Weisbach equation. Okay, so these are some review questions. State the Buckingham Pi method, write the criteria to select the repeating variables. These are the answers. Go through these answers. These are the references. Thank you.